Hello everyone, I hope you all are good. So today is our topic of interest is projectile motion and to find the equation of projectile. So what is the projectile motion? So projectile motion like if you see whenever you throw anything at some angle on earth, I'm talking on earth, not everywhere, because of the gravitational acceleration the things will go down. So whenever you throw something at some angle theta, the things will take a curvilinear path and then come back at some point. So this path the things will take is known as projectile. Basically it's a downward parabola if you see in xy coordinate system. So today is our topic of interest is to find the equation of projectile in x and y coordinates. So the first thing, the equation of projectile. So equation of projectile is known as path equation. So path equation are those equation in which the equation are only contain the coordinate terms like x and y. There will be no temporal term, means no time involved in equation. Are you getting it? So this will call path equation. Now to find the equation of path for projectile, you must know the components of a vector. Like if I write here any vector v, such as v1 I cap and v2 j cap. So what is v1? v1 is basically x component of v vector. Are you getting it? The v1 is the x component. Why x component? Because we write it with I cap, the unit vector in x direction. So v1 is the x component, so we can write vx is v1, and v2 will be the y component because it is written with unit vector of v2. This is the basic definition of a vector. So we have vy equals to v2. Okay, so for this particular projectile case, if we draw a projectile motion, like if you throw a ball, let's take a ball, and here this is our x coordinate and this is our y coordinate, and this is our origin. Like you are throwing something and you take your point as origin, means you are measuring everything from here. So we will take at 0, 0. So it will go like this, fly, and finally come down here. So the total distance covered in x direction we know that as range. Range means the range covered in particular x direction. So what will be its coordinate? Let's see, the total range we denote at as r. So here the y coordinate will be 0 because it's in x-axis, obviously. And what will be the final x coordinate? Because we take a total range as r, so r comma 0. Okay, and we will take any midpoint, like here, particular this point. Let here this particle be at any time t, means any arbitrary time. This is a variable, right? So at this point, if we denote its x and y component, we will write as x comma y. At this height be y and this covered distance be x. Okay, so we need some initial values to find these things. Let the initial speed, throwing speed be v, and initial angle be theta. So what will be the x component of that velocity that the ball is going up? So to find these x and y component, this is v vector, right, and this is angle theta, so it's x component. This vx will be v cos theta, the x component in the so vx will be what? V of cos of theta. How do we get it? This is the projection of v in x direction, okay, and its y projection will be vy will be v of sine theta. So these are the initial speed, okay, and we know that on earth there is a gravitational acceleration in y direction, so we will take ay is equals to minus g, because with the direction if we take, and if we take as a vector, so we have to write in particular manner, ay minus of g and j cap, okay. So this is ay, and we are taking acceleration x direction will be 0, means there is no acceleration in x direction, so ax we take as 0. So as we have got vx is equals to v of cos of theta, right, and ax is equals to 0. So from first law, if we see, we have v final is equals to v of initial plus acceleration into time, okay. So here we have acceleration and time, since in x direction if we write vxf and vx initial plus ax times t, and ax is 0, right, so vxf will be vxi, means the speed will not change in x direction. Are you getting it? So the speed will remain same in x direction but not in y, because there is acceleration in z. We will write, we don't need that equation. Why? You will get it in upcoming 2 or 3 lines, okay. So as we see, the speed in x direction does not change, so we can write the simplest thing, distance speed into time, okay, speed into time. So distance covered in x direction, the total distance we take it as range, and this is our range denotation r. Speed will be vx, and let the total time taken be t, means at any distance t, okay. So this is total time, right, not an arbitrary time. So for any point, as we have taken the midpoint x, for any midpoint x, means anywhere in the projectile, the distance covered in x direction, like this will be x, and the time here is t, so we can write x is equals to vx times t. Now put the value of vx, x is equals to v times of cos of theta times t, so manipulate x by v of cos of theta, let this be equation number 1. Getting it? Now for the y direction, as we can see, the initial coordinate will be 0, 0, and at any particular time t, the coordinate of y will be y, and so we can write the second equation as final minus s initial is equals to ut plus a by 2 t square. So for y direction, we can write y minus si0, and u is the initial speed in y direction, which is v of sine of theta times t, and acceleration in y direction is g, so g by 2 t square with the negative sign, because this equation is vectorial equation. So y will be v of sine theta, and put the value of t from equation number 1, x upon v of cos of theta minus g by 2 times x upon v cos theta whole square. Okay, so now we can write sin theta by cos theta as tan theta, and v will get cancelled out. So x times tan of theta minus g by 2 x square v square cos square theta. So as we can see, this is a quadratic type equation with x square, and x square's component is negative. So yes, this is a downward parabola. So here we can prove that this is a projectile motion. Thank you for your time.